Today we're going to be working on some diamond problems. Now, we've done diamond problems in the past. However, we were just doing those so we kind of understood how the process works for diamond problems. What we're actually going to be using diamond problems for is to find the roots of a parabola in a quadratic equation. So we're going to practice the type of problems that we're going to be using next chapter. And we're going to be looking at some methods in order to figure out how to solve these problems instead of just going, oh, I know it. We're actually going to give you a method so your brain doesn't automatically just have to jump to it. So if you don't see what the answers are to those diamond problems right away, we're going to be giving you a step-by-step technique that you can use in order to find those answers. So let's go ahead and grab our notebook out. And our title today is Diamond Problems. And once again, this is the type that we're going to have for the rest of the year. And they are a little bit more difficult than the ones where we give you the right and the left. So we're going to be giving you the top part of the diamond problem and the bottom part of the diamond problem. So first, a quick little reminder of what exactly that diamond problem looks like. If we have a number x and a number y, we go ahead and we multiply those together to get that top number. And to get that bottom number, we add those two together. Now, the way that I remember this, because a lot of people get confused, which one's multiplication and which one's addition, is I like to think that we learn addition first, so it's the easier problem. It's the lower level problem is adding those numbers together. And then after a little bit of math classes when we're in elementary school, we learn how to multiply. And so that's the higher level of difficulty because we learn it second. So we take those two numbers on the side, we multiply them for that higher level, that top, and we add them for that bottom. So that's just a way that I go ahead and remember those. So let's go ahead and take a look at our first problem, and then we're going to go through the steps of how to solve. So we're going to go ahead, once again, look at the top and the bottom, and we're going to find the right and the left. So in this case, we have a negative 12 up top and a 1 down below. So what we're looking for is we're looking for two numbers that are going to multiply to be negative 12, and those same two numbers need to add to be positive 1. So let's go ahead and take a look at those steps. Now, some people are just really great at this and they're just naturals and they look at it and they go, oh, I know the answer. And that's great if that works for you. However, there are going to be some that become more and more difficult. And that's why we're setting a procedure up in order to be able to solve those problems in case it doesn't magically pop into your head. So our first step is to find the factors of the top number. So in this case, our top number is negative 12. But as we're finding the factors, we're going to ignore the negative. We're going to find the absolute value. So we're just going to be looking at the number 12. And so we're going to go ahead and find the factors. Now, there are factors and multiples. Multiples are multiplying the number. Factors are the facts that make up the numbers, all the numbers that multiply in order to make up that number. So when I'm talking about the multiples of 12, I'm looking at those numbers that multiply together to get to be 12. And they are going to be integers, not decimals or fractions. We're going to have a different method, the quadratic formula, if we have decimals or fractions involved. So our first factor of 12 is 1 times 12. Always start with the number 1. That tends to be the one that people forget. And then I just go very systematically. So I ask myself, does 2 go evenly into 12? And it does. 2 times 6 is 12. And then I continue down 3. And I know 3 times 4 is 12. I look at 4. 4 is already there. 5 does not go evenly. 6, I've already counted for right here. 7 does not go evenly. 8, 9. Once I'm after that halfway point, I know I've found all the factors. And I already have 12 because I did 1 times 12. So these are the 3 sets of factors that make 12. So our step number 2, find the pair that adds or subtracts to get the bottom number. So I'm looking for 2 numbers that are going to add or subtract to get 1. So let's go ahead and go through these and see which one that's going to work for. So I know 1 plus 12 is 13, and I know 12 minus 1 is 11. Neither of these are 1, so I know that this is not my answer. 2 plus 6 is 8. 6 minus 2 is 4. Okay, neither of these are 1, so I know 2 and 6 is not the answer. 3 plus 4 is 7, and 4 minus 3 is 1. Ding, 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 ding. I'm looking for that 1. So I know that these are going to be my pairs. So step number 3 is write those numbers on the right and left of your diamond problem. Write those numbers on the right and the left. It doesn't matter which way you put them. So it doesn't matter which one's on the right or the left. So I'm going to go ahead and just put a 3 and a 4. Our final step, number 4, is to assign your signs. So I know I add them together. 4 plus 3 is 7. That's not going to do it. If I have 3 minus 4 and make that a negative 4, that's going to be a negative 1. But I need it to be a positive 1. So I know to get a positive 1, it's going to be 4 minus 3. And so that, ladies and gentlemen, is our answer for this diamond problem. We're finishing the diamond problem, finding the right and the left. And I know it's going to be a negative 3 and a negative 4. When we're doing our next chapter, we're going to take those numbers and we're going to put them into a generic rectangle in order to find a binomial for a quadratic problem. We're going to go ahead and try a couple more. Number 2, we have a negative 10 and a negative 3. So once again, I'm going to look at the factors of positive 10, just 10. So I know that that is 1 times 10. I know that 1 plus 10 is 11, and 10 minus 1 is 9. So I know that that is not my option because I'm looking for a 3. I know 2 times 5 is 10. 2 plus 5 is 7. 5 minus 2 is 3. Ding, 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 ding. I'm looking for a 3. So now I'm going to go ahead and I'm going to write my 2 and my 5 on my right and left. Now, I'm time to assign my sign. I need that to be a negative 3. 5 minus 2 is positive 3, so I know it's going to be 2 minus 5 to get that negative 3. Okay, let's go ahead and try a third. Our top number is going to be 21, and our bottom number is going to be 10. So now I'm going to once again look for the factors of 21. So I have a 1 times 21. That's going to add to 22 and subtract to 20. I'm looking for a 10, so I know that that is not my pairs. 2 does not go evenly into 21, but I know that 3 does. Now, if you're not sure, use your calculator. 21 divided by 1, 21 divided by 2, and it needs to not have a remainder. So I do know that 3 goes evenly. 3 times 7 is 21. I add those together to get 10. Ding, 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 ding. Okay, so I know I'm going to go ahead and pop those on my right and my left. 3 and 7. Now I'm going to assign my sign. Remember, they need to add to get this number. 7 plus 3 is 10. So my signs are already correct. They're both going to be positive. Let's go ahead and jump into a fourth example. We're going to have 6 of them all together just so we have a variety to look at. And this one's going to be a little bit harder. We have a negative 36 up top and a positive 5 underneath. So let's look at those factors of 36. Once again, I always start with 1 times the number itself. That is going to add to 37 or subtract to 35. I'm looking for a 5, so that's not it. I know 2 does go in evenly. 2 times 18. That adds to 20, subtracts to 16. Once again, I'm looking for a 5, so I know that's not it. 3 does go evenly. 3 times 12. Once again, you use your calculator, 36 divided by 3, to see if that goes in evenly. Those add to 15, subtract to 9. We're getting closer. You can see those numbers are going down, but we're still not there yet. 4 does go evenly. 4 times 9. Once again, use your calculator, otherwise you might miss a factor. 4 plus 9 is 13. 9 minus 4 is 5. Ding, 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 ding. I'm looking for that 5. So we're going to go ahead and put a 4 and a 9. And I'm looking for a positive 5. So 9 minus 4 is positive 5. And once again, remember, a negative times a positive will make that negative up top. Perfect. Let's go ahead and look at example number 5. Example number 5. So we have a 14 and a 9, all positive. So I'm going to look at the factors of 14. Once again, I always start with 1 times 14. That's going to add to 15, subtract to 13. I'm looking for a 9, so that's not it. 2 goes evenly. 2 times 7. So 2 plus 7 is 9. Ding, 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 ding. That's what I'm looking for. So I'm going to go ahead and put my 2 and my 7. Now, 2 plus 7 is 9, so they're going to remain positive, and 2 times 7 is 14, so I know that I've solved that correctly. Here we have problem number 6, our last example today. We have a negative 20 and a negative 1. So let's go ahead and take a look at that 20. We know that we have 1 times 20. Remember, we're going in order, so we have a systematic plan. That adds to 21, subtracts to 19. I'm looking for a negative 1, so that's not it. 2 does go evenly. 2 times 10. That's going to add to 12, subtract to 8. I'm looking for a 1. 3 does not go evenly because there's a remainder if I put 20 divided by 3 in my calculator. 4 does go evenly. 4 times 5, which adds to 9, subtracts to 1. Ding, 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 ding. I'm looking for that 1. So now I'm going to go ahead and put my 4 and my 5 on either side. I need that to be a negative 1. So I know that 4 minus 5 is negative 1. They do multiply. 4 times negative 5 to be negative 20. So I know that I've correctly solved this diamond problem. So ladies and gentlemen, we're going to go ahead and get some practice in our Desmos activity for the day.